today's lesson what a difference a sign makes. Now, by way of brief review, recall that the circular functions originated as follows. We said, consider the circle whose equation is x squared plus y squared equals 1. That's the circle over here. Then what we did was picking this as a starting point and taking any length t, we wrap t around the circle. When the length t terminated at point P, we defined what? Cosine t to equal x and sine t to equal y. That was basically the geometric interpretation of the circular functions, after which we showed that there was a physical meaning to this as well. Now you see what we'd like to do is the same thing, only with regard now to what I will call the hyperbolic functions. And you may recall that in our lecture on circular functions, I mentioned the hyperbola very briefly. Now I'd like to go back to the hyperbola in somewhat more detail. Namely, we now look at the equation x squared minus y squared equals 1. See, just a change in sign over here. The graph of x squared minus y squared equals 1 is the hyperbola. And by the way, notice already one significant change when we change the sign here. Notice that in the case of x squared plus y squared equals 1, our curve essentially came in one piece. Now you see our curve has two different branches. And for the sake of uniformity, for the sake of well-definedness, let's pick the branch that we will deal with to be the positive branch, meaning the branch that's to the right of the y-axis. To mimic precisely what we did in the case of the circular functions, what we do now is what? Given any length t, we start at S, mark t off along the upper branch of this double-valued curve. If t is positive, mark it off along the lower branch if t is negative. Wherever t terminates, we call that point P. And then to complete our analogy with the circular functions, we define the x-coordinate of P to be the hyperbolic cosine, written C-O-S-H, and pronounced cosh. Cosh t is x. And the hyperbolic sine is the y-coordinate of P, and that's written S-I-N with an H, hyperbolic sine, pronounced sinh. In other words, cosh t is the x-coordinate of P, sinh t is the y-coordinate of P. And in the same way that x squared plus y squared equals 1 gave us the circular identity that sine squared t plus cosine squared t is 1, the fact that x squared minus y squared is 1 gives us the hyperbolic identity that cosh squared t minus sinh squared t is 1. So again, notice great similarities, great differences. I'd like to make just a brief aside to point out how, in one sense,